Hey YouTube, it's JP Dillon. Today we're looking at a JVC model JR-s301mk2. This came in with a complaint of distortion associated with using the equalizer and problems with the phono circuit. So we're going to hook it up, turn it on, and see what it's doing or not doing, and then see if we can troubleshoot and repair it. These were very popular in the late 1970s. I don't really care for the plastic cabinets, but otherwise they're nicely made machines. They do have a couple of issues with the integrated circuits that run the equalizer, which may be a problem here. So let's go to auxiliary. Oh yes, and the plastic latches and these push buttons love to fail. Thankfully that has not happened, otherwise I wouldn't have taken it in. Let's see here. Let me get an adequate signal into it, since I'm at phono level right now. And let's turn up the volume. So far, so good. And let's see, let's turn on the equalizer. Looks good there, nice and clean. Got a little bit of a noisy pot there. Yeah, noisy pots. There might be a couple of peeing Panasonic caps we should change out, but we'll figure that out once we get inside. Balance control looks clean. Volume control looks clean, so I'm not sure what's going on here. Let's try the phono stage. Alright, let's go to phono. Let's see, the equalization's right. Yep, RIAA curve. Looks like it's happy. I'm not seeing any distortion though. If I press on the input selector buttons, we do get some noise and crackling, but that's just kind of typical for these. No excessive hum or rumble. And again, we just got a couple of dirty slide pots, so yeah. What's going on here? This is weird. Let's crack this baby open. Maybe we can figure out what's going on inside. Yeah, it's a little dirty. Gotta clean it out. But yeah, lots of Panasonic capacitors, of course. Of course. And so back here is his phono stage. And there's room in this estimate to recap the phono and the signal path if he wants it. I don't see any of these that have peed down the leads yet, but that doesn't mean they haven't. It's also only been on a couple minutes, so I'm going to kind of wait and see what, if anything, shows up. These are just so nicely laid out. I mean, look, here's your amplifier card that just pulls out. You can get to it real easy. I kind of like the 500 better because if you need to service the EQ board, it just pulls right out. This one, thankfully, has the orange Elnas on it instead of the purple Matsushittas, so I don't think I'm going to need to take it out. And this is an all-discrete one instead of using those silly ICs. I think those are in the 500. And this has got one of those MY3s like the 8080 and 9090 dB have. It probably needs, if I tap on it, oh yeah. Gotta clean those relay contacts. Definitely gotta dust it out some. But so far, other than some noisy pots and things, I don't hear his complaint about the distortion in the phono. But I'm very inclined, since that's really all he uses this for, is to change all these caps out. Now, I think they're peeing. Now, here's why I think that. If we zoom in, see that darkened area around the capacitors where the rest of it is kind of light? See that darkened area there? Yep, it's peeing. They're peeing. They must be French because they're European? No. No. All right. Let's take off the bottom cover and see if the pee's gotten into the board. Okay, so if we take a look at the phono stage here, there's no... Oh, nope, I was wrong. Right there. They're pissing into the board. You can see the trace there that's jacked up. Ugh. Alright. Time to bring in the Recapasaurus Rex. Gotta recap this thing. He's not paying for the full-blown, so we'll just be doing the ones in the phono stage since that was his point of concern. And then any others that are showing signs of peeing onto the board, we're going to change out. So let's go ahead and do that. Yay, a recapping video! So in addition to the ones that are obviously going to die in the phono stage here, I'm going to mark some of these other ones that I see. Like this one back here, if we can zoom in on that. You can see the fuzzy green crap that's coming out of there. So he gets the red mark there. That's going to go. And probably this guy here. Let's take a look down and see if the board's darkened around it. It is. So that's going to go. The little guys haven't peed yet, which is good. And let's see over here. It's hard to tell really. I don't see anything significant yet. There is a dark spot there next to that capacitor. It's really hard to tell with this lighting though. I might change them out just because. It seems like the lighter capacitors, the big ones pee and the little ones don't. Whereas the darker colored ones, anything between about 10 microfarad and about 100 microfarad love to pee, and the bigger ones typically don't as much. So let's take a look down in here. This is brought to you in Shaco-Vision. And I may pull this one up because it's got goos around it. But definitely the phono preamp back here, since we saw evidence of that, that has to go. There's a couple of them back there that need to get changed out. I'll probably change these out just because there's a high probability that they're going to be dead. And let's see, there's another one down here. Let's go upside down. Yep, that one's bad. So we're going to change that guy too. C190. These are all going to go. Like I said, he's not paying a whole lot of money. We're just to focus on what has to be done. And obviously all of those Matsushita caps going to go. Just like how these things are designed. I mean, look at that big heatsink there. And then we'll resurface the relay, because that needs to get pulled apart. Dust that out too. I didn't notice any hum in the sound on the scope, so power supply is probably good. And let's see, just do a little dusty here. Crustomatic. I'm probably going to take this outside and just blow it out. But for now. Okay, so let's start marking stuff. Okie dokie. So I've got all my little dead capacitors circled with little red marks. Those are the ones that are going to get pulled out. That guy there, that guy there, that guy there. Him, all these guys here. They're getting yanked. These two back here. So now let's just make an abbreviated map of their values. So if I screw up, I'll at least know what to put back in its place. Okay, I got my little abbreviated map of all the one I'm going to yank. Can't see what those ones are back there, but since they're the only two left, I'm not really concerned about it. So we'll just record them as we pull them. So let's get to desoldering. Okie dokie. Here comes the super exciting part where you get to watch me desolder all these things. Probably the least fun you'll have all day. But you got to do it. And when you get to these crusty ones that have peed, the solder removal really sucks. And we're probably going to have to clean up the board a little bit after we take all the old caps out. Because the electrolyte will get into the board and then it will cause problems. And that might have been what he was hearing. I only left it on for about 15 minutes. And I didn't see any noticeable distortion, but as the machine would heat up, or as the capacitor would pee, or create a leakage path into the board of the phono preamp, that would definitely cause issues. I think the distortion with the EQ is perhaps dirty slide pots, since he said it only occurred when he was using the EQ. But that's just me. And let's see, there's this one here. Just to give you an idea on Matsushita capacitors. I probably change out at least 100 of them a week. It really is. Purple Matsushita caps and old noisy transistors are really the moneymaker right now, because all these machines are just covered in them. You spend 2 to 3 hours per machine repopulating it, and although this one isn't going to take that long because we're just doing targeted rather than blanketing everything. This one's got a real bad case of capacitor P. It doesn't want to get the board clean. I'm sure this one down here is going to be a blast to remove. All right. Let's make sure I got everything here. Yeah, still a little bit of solder hanging on to that one. Like I said, the corroded electrolyte P keeps the solder from liquefying. You can dump a bunch of paste flux onto it, but that really doesn't do much. Oh, I missed one here. Squirrel. All right. Let's grab the hemostats and let's flip this around. And maybe shed some more light in here. I don't know. Lighting in here is crappy for movies. So let's grab and yank, assuming it'll let me. Like that one. Come on, dude, focus. Focus. See? Fuzzy green turds. That one's starting. You can see the dark spots there underneath. And there's this one. Yep, that one was starting. This 470 over here. Ugh, that one was really bad. No corrosion, but definitely wet the board. And then there's the glue that has to get cleaned up too. We got to do that. And then there's this one over here. That one was starting to die. And then let's see here. Can you see? Yeah, I guess you can see what I'm doing up here. Just grab it and yank it. Crustomatic. That one's not too bad. Yeah, see the 100s, that set of 100s there hadn't died, but these ones definitely. Ooh, that one's peeing down both leads. Usually it's just a negative. And then there's two back here. Flip this over so I get a better grip on it. No. That one popped out. You know what? I don't think I desoldered those yet. That's why that one was giving me such a fit. Nope. I did not desolder those yet. That's these guys up here. Okay. Let's try this again. Let's reach on up here and grab the first of the leads that were left behind by the cap I yanked out. Easy peasy. And then pull another one of these out. So these are all, those ones that I did not have marked on the map were 220 microfarad low voltage. Okay, I'm just taking some notes here. Hold on a minute. So we got two 47s at 35. And we got three 100s at 35. Actually, we got five 220s at 35. And then a 470. 35. Okay. Now, these might have been 16 to 25 volt caps originally, but all I have is 35 volt caps and those values. All right, make sure I didn't miss anything else that I marked, and I did not. So let's clean off the board where all the caps sat. And the first place is going to be this guy right here. And I'm just lightly scraping away. I'm just using the back end of the X-Acto, not the super sharp side, because this is just getting rid of the chunks of glue and stuff that are there, and then we'll use isopropyl to clean up this mess here, because that's really all that's there as far as yucks. Okay, so here's my isopropyl. 99%, no water, and we're just gonna get aggressive and scrubbing that and that and that. We'll do the back side too. Just want to make sure there's no residue left over on this board surfaces. It might have lurched into the board somewhere, but the voltages aren't high enough, and I don't think the propagation is big enough that it's going to be that much of an issue. So scrub underneath here. I use this because it dries without any kind of moisture or residue. And return to this spot here since we didn't get this yet. I can just blow on it and dry the board out. Goes pretty quick. Okay, let's do the back side. That's going to erase all of our Sharpie marks, but who cares? And after we're done cleaning this, we have to take a look and make sure that there's no foil traces that have been damaged by the pea, because that can happen too. Like this one up here that was really bad. I'm just going to do a little quick scrape test and make sure that this foil trace is still attached here, which it is. And there was another one down here. This one's kind of ugly too. But it didn't kill anything, so that's good. So now really it's just a matter of repopulating this thing. Putting all the caps in the holes and then soldering them up. This could use a little more removal. And again, I'm just using the blunt side of it so that I'm not scratching the board to hell. And we'll clean that up again. Some stainage there, but not bad. Alright, let's go get the caps that we need. Alright, so we got our necessary replacement capacitors, and I'm just using mostly Nishikon UPW and Panasonic ECA and high hour, like 5,000 hour Rubicon type stuff. it's not super duper high grade capacitors, but the point of it is that their service life at the rated temperature and voltage is 5,000 hours or more, so they're going to take the punishment. And I'm more concerned about that than I am, you know, ultimate and high fidelity. So let's go ahead and start repopulating this. So what I'm going to do is just start putting them in here. And then we'll fold the leads out on the back side so that they stay put. And let's see, there's a 47 at 35 that goes down here. And let's see, where's the other one at? The other one goes up here. That was in the tuner section too. I never really checked FM performance other than the fact that it worked. And then we got 100 at 35 up here. And let's see. We got this 220 over here. And if you've seen enough of these videos, you pretty much know by now that I just kind of, excuse me, I do everything in blanketed steps. So I take inventory in a blanketed step. I do part yanking in a blanketed step after I've made absolutely sure what goes where. I like to do everything in batches. Now, if I'm flying absolutely blind with no literature or maps or anything, then yes, of course, I'll do it one by one, and I'll try not to let anything distract me, but this is the most efficient way I can think of doing it for me. It may not work for you, you may have different methods, but this is how I do it. Okay. Like I said, kids, recapping videos are boring. So if you want to fast forward through all this garbage, you're more than welcome to. I much more enjoy the troubleshooting aspect of repair than just replacing parts all day. You may have seen the previous video about the Sansui 2000X. That was a real straightforward problem with the multiplex, and it was just fun to target that and do it really quick. And it wasn't really a difficult repair, it was just finding the defective part. Alright, so let's spin this back around. And to get rid of the glare, we'll turn this off. And then we'll just solder all this stuff up. Trim the leads off and then see how it runs from there. Oh, that's right. We still have to clean up the protection relay. Really hot iron, about at 800 degrees. And a good tip that's clean takes care of solder work really fast. You don't want to prolong the time that your iron's on the work area. And you want the solder to flow really well. And since I cleaned all the old electrolyte garbage off of the foil traces, the solder sticks really well. Normally you're going to have a hell of a time just soldering a new part without cleaning the board, so I highly recommend you clean the board. And we'll take our flush cutters and get rid of all the extra leads. Funny story, we had a representative from the county of San Diego come out. And they do an audit to see, you know, are you properly disposing of your hazardous materials, blah, blah, blah. And she made a comment about how you can't really recycle these, and you know, you got to throw them away when you can't fix them anymore, and all this silly nonsense. And I kind of said, you know, we're probably one of the leading people in San Diego County that keeps stuff out of the landfill, because we're fixing all this old gear rather than throwing it away. And she was just didn't think it could be fixed. I guess she was just conditioned to believe that once electronics die, you take it to e-waste. Okay, I'm just checking the orientation of everything against the little map that I drew, and everything looks good here. So we're good with that. While I'm at it, I think what I'm going to do is I'm going to clean all these slide switches. And I'm going to use fader lube because I don't trust that the CRC is going to not hurt the plastic, and we're going to use it very sparingly. So I'm just going to spray a little bit inside the little holes here of the switches. And we'll just work them 4 at a time. Because the failure mode is that people use too much cleaner or too aggressive a cleaner, and the little plastic latches fail, and none of the buttons ever stay in again. So you gotta be really careful when you clean these switches. All these style latching switches that use these plastic latches back here, they all suffer if you use too much cleaner or the wrong type. So I'm using fader lube because it's a little bit better on plastics than deoxit or CRC is. It's a different formulation. Those are the speaker switches. We'll do those last, but I'll soak them up really good. That's really the death knell for these, is when the switches fail. And it's usually because people use too much contact cleaner, and none of them stay in. And yes, there are switches that you can replace those with, but it's such a chore. And if you got to do all of them, it's just depressing. Just don't do it. All right. That should be good for the switches. I noticed that the tuner wheel flywheel starting to come out here, so let's push that back in. Don't need that coming out. And then let's see. Really just comes down to cleaning the slide pots now, since we did experience some dirty slide pots on the EQ side. Let's turn that off so we have less glare. And I'm going to push these all to their extreme, turn up the spray a bit, and just spritz a little bit inside of each one. Again, sparingly. And just work them. You don't want to use too much because it will wash out the silicone in there. It's too bad he's missing one of his little knob covers, otherwise that would have be a perfect looking set. I'm probably going to have to start another round here because my memory card's filling up. I got to empty this one out. All right, it's a good stopping point. Let me dump this card and then we'll come back with more. Okay, so we're back on this JVC thing. Let's see, back to Phono. Phono looks pretty clean. Just looking at it on the scope back there in the background, you can probably see it. There's a lamp that burned out. Or maybe I just didn't notice that. Anyways, we can change the lamps. That's easy. Nice clean movement of the slider controls. No crackling or dropout like there was previously. Very nice. We still have to do the relay. Haven't done that yet. Pressing these buttons though doesn't cause any dropouts. That's good. Alright, let's assess the lamps. Now I'm pretty sure that these are just 8-volt fuse lamps. And the way you get back here is you bend those tabs. See, you got one here and you got one there. You just bend them just enough to get the lamps out, and I'm going to change them because we've obviously got one out. They provide illumination for the entire dial via a diffuser that's at the bottom of the meter assembly. Yeah, so let's go ahead and do that. That's pretty straightforward. Okay, I've tried to position this best I can here because it's very difficult to fit a camera in, so I'm kind of like, I don't know, the camera's way back where I'm sitting really, so it's kind of in my way. Let me get that started with X-Acto, which I've just lost the blade to. That's great. And let's get a pair of pliers and very carefully bend this out. And we'll see if we can do it only bending one out rather than both. See if it wants to do that. Yes, because the last thing I want to do is fatigue that tired old metal part. So we're going to take the old fuse lamps out. They just unsnap pretty easy. There's the holders. I don't know if you can see that, but they just pop out there. And let me get some fresh lamps to put in it. These are 8-volt, 250 milliampere. And see, they just click in like so. And then let's slide this back over here. And there we go. And bend the tab back over. And that's lamp number 1. Now I got to do lamp number 2. And we'll just repeat the process here. This time not losing the X-Acto blade under the bench. Now as far as where to get lamps from, if you want incandescent lamps, you can go with either Joseph Mirabella. I think he's like Project Block 86 or something on eBay. Or you can go with Dave Wojnarowski, known as Dwojo. He's visible on Audio Karma and other places. I believe he's got a website too. But I've been getting lamps from Dave for years. And I recently started buying LEDs from Mr. Mirabella, and they're pretty decent. Pretty close to the originals. I still like incandescents better, but they're pretty close. Nice luminance. They have built-in resistors, protection and filtering so they don't flicker. Very nice kits. Alright, so I had to do both tabs on that one, which I'm not thrilled of. And then I have limited movement because of the wiring harness that's in the way here. So I'm just going to take the old ones out. And puts 2 new ones in. And yes, they're going to be a little bit lighter colored because they don't have the blue vellum wrapped around. But it actually turns out for a much nicer, kind of like a sky blue color. Okay, and let's put this back. And fold these down. Okay, so that takes care of the dial lamps. Let's see how it looks. Alright, how's this look? Yeah, it's pretty decent. Camera really doesn't show it here. Let's see if I can back off on the illuminance a little bit. Yeah, because normal, there we go. It's hard to tell on camera. It's a really nice sky blue. Very pretty. Okay, so the next thing we have to do is clean the relay because the relay is just yucky. I don't know why it's not allowing me to, there we go, adjust exposure. So let's do that. Okay, so with the relays not being exceptionally fun to get at, in order to take the relay out, physically desolder it from the board requires an extensive amount of disassembly of the amplifier. And so I've been down this road before, and there is a tool for this that I have created. And so it's basically a modified dental pick that allows me to get underneath the relay cover and pop it up so that I can get to the important parts of the relay. Of course, that also helps that it's free and clean of debris, because it ain't going to hook very well if there's stuff in the way. So bear with me one moment. Let's make sure this is clean and sharp and it grabs. There we go. And so we're going to slip the hook portion underneath the case. Pop one side up. And then pop the other side up. Ugh. Come on. I just popped the other side down. I probably did. Nope. There it goes. So that comes up. And then the next thing I want to do is detach the spring without losing it. And then pull the contact assembly up. There's some oxidation on those contacts for sure. A little bit of pitting there, which tells you they left the volume up a lot when they turned it on and off. So what I want to do is I want to see how bad the surface is, and I'm going to touch this with my pick, and if it catches, like that one catches, so we need to resurface this one. This one's pretty rough. So what I'm going to do is grab some 2000 grit ultrafine, and we're just going to do a couple of brief swipes of this. Just hardly any pressure at all, and just clean off the gunk there. We can see there's a little bit left up top, but hardly any pressure. You don't want to influence the surface area too much. So that's much cleaner. And then we have to do the same thing for the contacts down on the relay body, and let me show you how I do that. We're going to reinstall this first. And coincidentally, the same hook tool that helps me get the top off also helps me reinstall the spring without it going too far. So we're going to get that around that post there. Put this back up in its place. This one's wanting to fight me. There's always one. Okay, I'm going to put my finger behind the spring so it doesn't fly off if I lose contact with my tool, and then stretch the spring back over here. Move this up until it hits the catch there. There we go. All right, so now that the relay's in, I'm going to feed the sandpaper between the contacts where it would strike the contact plate there. And then we'll get our tiny needle nose pliers, grab a hold of the sandpaper, press the contacts closed very gently, and just do a couple swipes here, clean it up. You don't want to press too hard because that will bend the contacts. It's just enough to close them. And then clean it up with the sandpaper. Oh, it's hard to see that there, but that's what I'm doing. Okay. And before we pop the cover on, we'll do a brief test with it hooked up and see if we can influence the sound. Okay, so if we wiggle the contacts on the relay, we see that the left channel is still kind of cruddy. That was probably due to the heavy pitting there. It could also be due to residue left over. So let me remove the signal here. And then we'll get some contact cleaner on it, some CRC. And I'm just going to spritz a little bit in here. Then grab the relay and work it across the contact base, and that hopefully will clean up any remaining garbage that's on the contacts. Turn it up here. Still not great. Alright, so we need to get more aggressive about cleaning that. Now, I don't think shooting it from a different angle is going to help me at all. This holds the camera a little bit more steady. And the left channel over here is pretty ugly. So that amount of pitting that's there is just too yucky. So we're going to have to surface this a little bit more. And then do the same for the contact plate. And there's not enough money in the estimate to replace the relay and the time needed to do all that disassembly. So we're just going to make the best of this. And see, I keep bashing the camera because it's like right in front of my face. Let's get this back together. And then we'll run the sandpaper through the inner contacts again, and then we'll see if that helps anything. Hopefully this is a better angle to see how I clean the inner contacts. See how well this works. All right, let's try this. Okay, scope looks happier. Let's see. Alright, so now if I grab a hold of the relay contact, we get minimal influence there, even wiggling the crap out of it. I have to like pull it off the contact in order for it to be really bad, so I think this is as good as it's going to get. We can try spraying some contact cleaner in there again. It's getting better. Just working it a bunch. I just don't want to see any more flutter out of that side. Alright, that's about as good as she's getting. Okay, so we can put the cap back on it. Eventually he'll need to get a relay. This will get really touchy again if he doesn't take better care of it. Okie dokie. And let's get to doing some setups. Okay, so let's go to FM. Let's see how well our FM works. Turn muting off. That's pretty close. Needs a little bit of a tweak. It's actually reading 98.3. So let's make a little adjustment. The local oscillator should be this guy. Let me get an appropriate tool. Bear with me since I have to grab my tools single-handedly. Okay, so let's spin it to 98.5, and then let's adjust our local oscillator coil, which is this guy right here, until we see our test pattern. And then we'll zero it in. All right. That looks good. And let's see if when I turn off stereo here and we decrease our signal, no, not detector's wrong. See how I get the noise on the top but not as much on the bottom? Let's adjust the tuner until it's symmetrical. There we go. Alright, so with symmetry, now it's slanting to the right a little bit. So we're going to go to our detector coil right here, and I should be able to zero that out. No, because I'm adjusting the secondary, not the primary. And somebody stripped out the primary. That's great. Let me see if I can get it better from the bottom side. If it's even possible to access from the bottom side. Let's see. Nope. Now they've got that blocked off. Alright, let me desolder that and try it again. Yeah, that's a nope. Even when you desolder it, it's just a freaking pad. Like you can't get to it unless you're topside. And sometimes if the guy rounds it out with a stupid tool, you can still get to it by feeding a regular tool down inside here. The top one's good. The bottom one is just like rounded out. You hear it not catching in there. Ugh, I hate that. Let me see if I have a different tool. And one that fits a little more snugly maybe. Yeah, because I'm not happy with that, the way that tuner looks there. Trying to zero it out so it looks acceptable on the scope, and then, yeah, I don't know, it's pretty damn close. Yeah, maybe we'll just make a note on the paperwork because this is stripped out. Let me see if I can find another tool. Alright, we're going to try this. Let's see if we can't zero it out this way. It's just freaking stripped. It's just so badly stripped. Alright, let's just peek out the top one then. It just is what it is. Alright. And then we'll just do a quick RF touch-up. Turn it down until we start to see a little noise. That's signal indicator 3. And I'm going to adjust my RF trimmers here and peek this out. I'm adjusting it at the middle of the dial so everything's kind of peaked out overall. We're just watching the signal strength meter there. Peek that. It's not a full alignment, it's just touch-ups. And then the second one is over here. just peeking that. All right, that's as good as it gets there. Add more signal, turn on our pilot, turn on our stereo function, and that multiplex looks really good. Nice separation there. Okay, so the last thing to do, let's turn all the volume down. Let's check our DC offset. And you can do that really easy with a scope, because we'll just make sure we're on a flat line here at ground, and then we'll go to DC, and we can see that it's pretty much near zero here. There's maybe a millivolt or two. Not enough for concern. I'm not going to go tweaking that, don't need to. And then bias. Let's see what they want for bias. And just looking at this, there's like no visible test points. Not for a bias adjustment. And your emitter resistors are tucked in back there. So I'm not sure how that's going to go down. Lots of crusty dirt back there too, and there's no easy way to attach any kind of test equipment there. So let's see what the service manual says. So that little row of pins that we saw wedged in down there, you're supposed to have a connector to hook up to that. Yeah, that's great. Okay. Well, anyways, idling current's 10 millivolts across the emitter resistor pair. So, yeah, let's see if there's a way that we can get to that. Maybe it's on the bottom side. Yeah, no access from the bottom side. That's the test port there that they want. Let's see. And they're just saying, oh, you can just shove a meter down in there. No, you can't. No freaking way. No wonder people blow these things up. And looking from the bottom side, there's no way to access that. There's no service port there. You can't do it. Now what I can do is remove this board and then attach meters to it with clip leads. I guess that's what we're going to have to do. Yeah, so here it is with the board out. And there's our test points right there, which is what you have to clip onto. So let's get some clip leads and run up to 2 different meters so that I can monitor it simultaneously, and then we can make adjustments. Holy crap, what a stupid design. Alright, so there we are. We got it all clipped in and everything. And I got one set for one channel and one set for another channel, so we're going to grab 2 meters and wire this thing up. And this is it with the board back in place, and you can just see how crammed it is in there. And yeah, so they probably had a service connector that they would use to get everything situated for you. And obviously you got to do this method, otherwise you're not going to be able to adjust it, because how the hell are you going to get probes and stuff in there without blowing it up? Anyways, let's go grab our 2 meters, and then we'll set it for the appropriate voltage reading, let it warm up, and all that jazz. Alright, so we've got another issue to overcome here, and that is that we're not getting any bias reading at all. And I've double and triple checked everything, and it's just, we get that tiny little bit, and it's not adjustable. Now granted, there's no crossover distortion, and I get voltage across the emitters when I fire it up. So yeah, I'm not sure what's going on here, but the heatsink is ice cold, and it's just no quiescent current whatsoever, and that's in both channels. So let's take a quick look at that. Okay, so now if I come over here to this visible output transistor here, and we go down here to the base, 88 millivolts. What? That can't be right. Oh, wait a second. Let me see something here real quick. Bear with me, I'm just trying to check all this. There's plus 42. 90 millivolts and 9 millivolts. Now, if these were truly off like they should be, yeah, something ain't right here. Okay, there's something I need to explore, because on these JVCs, remember how the bottom plate had a screw in it with a post like that? I wonder if this just needs to be grounded. And maybe we've got some kind of weirdness going on here. Yeah, I'm not sure. Does this change anything? Am I now at some sort of truly referenced ground? Because before, I was like getting weird readings. Of course, I was getting the rail voltage, but none of the rest of this stuff. It's weird. Let's just check here. Do I have... Yeah, I do have continuity, and with that disconnected, I still have continuity, so that's not it. So we just have erroneous readings on the amplifier that are not okay. And let me see if I can get some clip leads between the base emitter junction and see if it's truly off. But there's no distortion like it would be off, so that's weird. But I can't take the bias reading that they say because there's no change in voltage, which worries me. Alright, so let's take a look here. If we come over to the base of this transistor, the NPN, we see here that we have 80 millivolts. And if I come over to here, of the PNP, there's my base voltage, my minus, half a volt. So that's what I would expect, unless this is some sort of weird quasi-complementary thing there. Nope, it's NPN, PNP, so that's, that's how it should be. Let's come down here. Again, I got that. When I come over here, I've only got partial bias there. It's 0.3 of a volt. So there's something going on here. Let's pull this amp card and take a look at it. So this is one of these cards that has all those little fusible type resistors on them. And I wonder if they're open. That 10's alive. That 10's alive. Should be like a 470. Let's see, is there a corresponding one over here? I don't see it yet. Anyway, let's look at this. 1K, 1K, 2.7K, that's red, purple, that's about right. There should be a corresponding one over here. What? Oh. That should be like 100. Well, that isn't right. 725. Is that a brown or is that a red? I guess it's a red, so that's a 220. So that's normal. We already looked at this one, right? Yeah, 2.7. Here's another 220. Here should be a 10. Another 10. Another 10. Another 10. 220. Big old 3.9 ohm, which you can't see because my hand's in the way, but it's there. 2.2 ohm. Another 3.9 ohm. Yeah, so nominally that looks good. But let's take a look and see what would be causing PNP bias, but no NPN bias. That's a very interesting failure. Alright, so looking at this, I'm trying to figure out what would cause a loss of NPN drive, but not a loss of PNP drive. So here are your outputs over here. And it's the same symptom, although one channel has it slightly worse than the other. And that is that there's just very little voltages on the base here. They say they're supposed to be 0.6. We were seeing like minus 0.52 and, you know, minus 0.518 or something like that on the PNPs. But the NPNs don't have diddly squat. So following this backwards, we did check the 220 ohm resistors, which are not open. That's kind of like a pulling them together kind of thing. And then let's see, we've got the drivers here. I mean, we could be getting a loss, like our bias adjustment resistors here. We could be getting a loss of voltage here because we've got drive that comes off of this array here that goes to these. I think this is your class A. This is your bias transistor with the adjustment there. So, and I believe that was open. Yeah, we could have a shorted diode there, bad diode, that could cause it. One of those capacitors, the 47 microfarad, could be leaky, but leaky in both? That would be kind of strange. I do need to check those transistors, though. They just have one channel up top and one channel on the bottom, so it's the same thing. I gotta think about that one. That was a strange one. I think I'm gonna start checking components, and really my point of concern primarily is the little diode, these SV things here. Because if that was messed up, if they were like, you know, leaky or shorted, that would definitely kill the bias and still allow for enough current to turn it on. It's just basically being turned on by the signal right now. Inner ramblings. So yeah, but the surrounding resistors all check out, so that's out of the question. So we need to check and see that our bias transistor isn't shorted and that our diodes aren't messed up with these SV things. These could be messed up. That one's like open in that direction. This should be the cathode though. Yeah, so there's your dual junction there. So that one's okay. Dual junction there, so that one's okay. We look at 705 and 706. That's your bias regulator. Actually, no, that's your class A driver there. So 706 must be the... Unless that's on the heatsink somewhere. I don't see it on the board. 707's there. Of course, you have 707 here. That's 719. This board is just so dense. You got 1, 3, 7, 9. Those are your drivers. These are your drivers, obviously. This one says 5. This one says, I guess that would be 6. 5 and 7. Because these, oh, there we go. Yeah. 5 and 6 here. That's your class A driver. And then, let's see, 719 and 720. Those are your bias devices here. So there's 719 and there's 720. So if these are defective, they would definitely pull down the... well, those PNPs are NPNs. They're all NPNs, okay. So he tests happy. No leakage there. He tests happy. Nothing going on there. Okay, so nothing wrong there. At least nothing obvious. So these aren't defective. These nominally are okay. These are nominally okay. So then we'd have to wonder, is there a loss of gain with the NPN drivers that would cause that issue? 2SD381s. I mean, they aren't going to be open, or we get distortion. It's just not getting enough bias. The bias should be generated by the Class A driver. Yeah, so we have to think about this one. This one's a little tricky. Alright, so I went over the board and I did some resoldering because there was lots of loose connections. And then I thought to myself, well, that's not really fixing anything, so let's take a look more closely at the bias circuit. And so the bias circuit, you've got 719 and 720 that controls 705 and 706. And I'm thinking, well, if this is messed up, if these are conducting too much, these will conduct too much, and these will pull these two together. I noticed that the bias adjustment down here did absolutely nothing. It just did nothing. 720 does nothing. So I'm like, these are hard. These must be hard on. So I took a measurement across the base emitter junction. Yes, they're pretty hard on. So I'm pulling these ones out, 719 and 720, which are the little TO92 guys here that reside right here and right here. And the first one I yanked has a beta of 700. Yowza! So let's do an experiment here, fix the load. Like a beta of 700 means if a milliampere goes in, 700 milliamperes goes out. Yeah, so that's kind of a concern. Alright, let's test the other one. The other one's, as you can see, 628 and it's climbing. So that's kind of weird. These are 2SC 1775s, easily replaced with the KSC 1845. Let's see what happens when we put something in there that's got a beta of like 400 instead of almost 7. That's crazy high. That's going to make the control circuit way too sensitive. I also want to pull and test the Class A drivers. Or actually, no, these are the other... No, this is the Class A driver. These control the Class A driver bias circuit, so I want to make sure that those are okay, because if these are leaky, well, no, if these are leaky, that doesn't do anything with that, so ignore that, forget that. If these aren't putting out enough current, then we won't have anything to adjust, so we need to look at that too. Let's just yank those real quick and test them. So this is one of the Class A devices. This 2SC 1904, and that's about right for that device there. So I think really our bias control circuit is just too sensitive. So we're going to put some lower gain devices in there and see if that helps our situation at all. Okay, so I got our 300 beta KSC 1845s in there. Let's pop this back in and see if that changes our situation any. Okay, so we're still having issues with our delivery of the drive for our NPN. Not much drive there. When I come up to the Class A circuit though, we have our proper 1.1 volts there. Let's see about the supply voltage to the drivers. Yep, we got minus 43 there. We got plus 43 there. And if we go to the base, we got 0.6 of a volt there, which is about right. And if we go to the base here, we got minus 1.1 volts. So that's wrong. We got too much drive here and not enough there. Same with the other one over here. Let me check this one. 0.8 of a volt there. And minus 1 volt there. So clearly we have still something going on in the driver stage. Let's take a look at something else that could be a possibility. Now I think I checked the emitter resistors here, but these could be drifted up and this could not be conducting. Particularly the NPN or PNP was the one that was problematic, I think. So, yeah, let's see here. And then we got these two diodes, which we checked. Those are the dual junction diodes that are okay. But I'm just not getting no bias. It's a puzzler. Alright, so I think I know what's going on here. I checked the circuitry, and everything per the schematic checks out. So my only conclusion would be, since I was getting proper voltage here at the bases of these, and I was getting low here, either the supply voltage would be wrong, like the resistors here out of tolerance or something, which is not true, the supply voltage is low, which is not true, or the transistor is loading down the circuit. So the fact that this driver has only a beta of 30 means that the previous stage, the Class A stage, has to work harder to push into it. It may simply not be able to provide the current. So I'm going to check the NPN or PNP just to be sure, and the other NPN, but I think this is the root of our cause. See, the PNP is a little bit better at 80, but if we go back to that NPN, that was like 30. Yeah, that's not good enough, not for that circuit. They've got a Darlington providing the bias for two drivers, and if they aren't matched, one's going to hog current more than the other, in this case the PNP. So let's get some fresh transistors in there. So for the NPN, the MJ15032 has a beta of 98, and MJ15031 for the PNP is 75. That should work. Okie dokie, I'm on the truth here. So now I can go to the base on this one. We have our positive voltage here. We'll go to our negative, and we have our negative voltage. Alright, so let's go ahead and repeat with the other channel, and then we'll rebias it. Alright, so there was another issue. The drivers helped a little bit, but we still didn't have enough oomph. And then I remembered something. The thing I remembered was that the diodes here, which are an SV03, that's a 3-junction diode. When I pulled those were 2-junction. They'd been replaced. So really what it came down to is my thoughts were, since these were in the 700 betas, these were driving this too hard, which was making this too hot. And so somebody replaced the bias diodes rather than pulling and checking these. So I'm going to replace, or actually I'm going to take the 2-junction diodes and add a 1N4148 series to make it a 3-junction. And then we'll pop it back together and see if it works. And you can see there they are. I've tacked them in series. And so now we'll hook the meters up again and see if that does it. I'm thinking it will. Alright, moment of truth. And there it is. Look at that, it comes right up. Comes right up. Let's see if it's adjustable. You bet. Cool. Nice and happy now. Clean signal, good bias. Everything's working. So we're going to wrap this one up. Thanks for watching, and more stuff to come.